Hello, my name is Gordon Klok. I'm with the SRE team at Demonware in Vancouver, and I'm going to be talking a little bit about it's more of a post-mortem plus kind of a cool thing that we did. When you start to have problems when you have lots and lots of MySQL servers, and you need to do simple things like backups can become quite challenging. A typical, large Demonware MySQL cluster is probably about 200 machines. We do nightly backups, of course. Typically put them through, we use Percona's Extra Backup X. There's not enough space on an individual machine to actually have both a working copy and the backup, so we stream it to a storage appliance. This process has worked great for probably 3 years or so. No problems. Do it during the backup window, because of course Extra Backup can actually affect MySQL while it's running. It holds locks, it starves I/O, that kind of thing. No problems. Until recently, we consolidated 2 of our DCs together, and we started seeing this. Well, the Dublin guys started seeing this very early in the morning, every single day, and it's terrifying if everything goes red at once. We started to do our kind of triage, figure out what's going on, sort of follow the use checklist from Brendan Gregg. It's very cool. It's not the individual database servers. We could do a backup, works fine. What we were actually seeing is that when we do parallel backups, all of a sudden everything starts going wrong, even though there's plenty of I/O. What it was our NAS appliance. We were seeing, during parallel backups, we were seeing that's 300 or 3 million. It's 3 seconds to write 165K block. The problem, so why was the slow NAS, though, causing MySQL to screw up on individual database nodes? Turns out this is kind of a Linux kernel problem. It's actually fairly well known about. If you have a slow I/O device and you're writing to it, the page cache, when you write a file, of course, a kernel page gets marked as dirty, and then sometime in the future, Linux will, when it's opportunistic, will write it to disk unless you do an fsync or something like that. What was happening, though, was the PD flush thread, if you hit 30 seconds of a page being dirty in the cache, Linux will start blocking I/O for processes trying to write or in order to make sure that those pages start getting flushed. So because our appliance was malfunctioning effectively, we were getting 750 megs of dirty cache in those 30 seconds. Impossible to write over gigabit that quickly. So what we did, I know BackupX actually has a rate limit, but that's only going to affect the local disk. That wasn't, in our case, the problem. What we did was stick PV between Extra Backup and the NFS appliance, and we used a static limit. And for a while, it actually seemed to improve things. There's 2 problems, though. The machines, if you set it too low, then I know Extra Backup can't actually finish. It just keeps writing logs until it actually fills disks and kills it. And if you set it too high, then obviously you interfere with the local I/O. PV is a very cool feature, -R. You can actually adjust the rate limit after the process is running if you know the PID of the PV process. So you have a way to do this dynamically. We also, while we're debugging this, we found out that if we kept the average queue size from IOStat at 1, the system was healthiest overall. Like MySQL was working in the back. So now we had a way to get a metric. We had a metric. We had a way to dynamically control the rate limit. We needed a way to we needed an algorithm to actually do this. So we used, this is a very old technique, PID controller. It's from the 20s, from an industrial process. Basically, it's a feedback loop, and what we ended up doing was writing a Python script that would just watch the IOStat output, adjust that dynamic rate limit, and this was what ended up controlling it. So this is about a month of backups. These are our worker time spikes. It's pretty severe. We introduced tpain, and then because we now had the ability to control the dynamic backups, we were able to actually schedule all of our backups. And that's the NFS latency going away. It's gotten even better than this recently. So I'd like to be able to open source it. Unfortunately, due to time, I wasn't able to do this before this talk. But if it shows up, it'll be at at Demonware's GitHub page. If you want to try to recreate it, hopefully the slides gets posted somewhere. This is at most maybe 200 lines of code, so you can probably just recreate it yourself. Thanks.